Hello dear students, all of you welcome to Vidyan classes. Today we will discuss some more important problems from elements of mathematics. In lecture number 6 we have discussed question number 9 from first bit to 10th bit. Now we will discuss 11th bit. Prove that the value of the determinant is a plus b plus c whole cube. Prove let del be the determinant having elements a minus b minus c. 2a, 2a, 2b, b minus c minus a, 2b, 2c, 2c, c minus a minus b. To show del is equal to a plus b plus c whole cube. To show the value of the determinant is a plus b plus c whole cube. Applying row 1 replaced by row 1 plus row 2 plus row 3. Del is equal to applying row 1 replaced by row 1 plus row 2 plus row 3. It gives a plus b plus c. This plus this plus this, which is same as a plus b plus c. This plus this plus this, that is a plus b plus c. 2a plus b plus c minus a minus b, it is also a plus b plus c. Row 2 remains silence. To be b minus c minus a to b. Row 3 remains silence. To c, c minus a minus b. Clear? Applying row 1 replaced by row 1 plus row 2 plus row 3. Implies del is the determinant. Taking a plus b plus c as common from row 2. A plus b plus c into determinant having elements 1, 1, 1. To be b minus c minus a and to b. To c, c minus a minus b. Whenever a scalar is multiplied with a determinant, then it will be multiplied in any one of the rows or columns. It is the scalar multiplied along row 1 gives this result. Applying C1 replaced by C1 minus C2 and C3. C2 is replaced by C2 minus C3. C2 minus C3. C1 is replaced by C1 minus C2. Our motive to get the maximum zeros in any row or column, which is same as A plus B plus this minus this, that is 0. C1 is replaced by C1 minus C2, it is 0. This minus this, that is A plus B plus C. 2C minus 2C, that is 0. 1 minus 1, that is 0. This minus this, minus of A plus B plus C. 2C minus this is equal to 2C minus this B plus C. Column 3 remains silence, that is 1 to B C minus A minus B. Clear? Row 1 contains 2 zeros. Column 1 also contains 2 zeros. We can expand along row 1 or along column 1. Expanding along row 1 implies del is equal to A plus B plus C 0 into its minor is 0. Minus 0, the sign of this element is negative. 0 into its minor is also 0. Plus 1 into its minor, plus minus plus. It gets A plus B plus C minus A plus B plus C 0 A plus B plus C, which is same as A plus B plus C into 0 minus 0, this into this minus this into this. A plus B plus C whole square minus 0, which is same as A plus B plus C into A plus B plus C whole square. Implies this del is equal to A plus B plus C whole cube. Del is the given determinant. So the value of the determinant is A plus B plus C whole cube. Hence, the statement is proved. The value of the determinant, which is taken as a del, is equal to A plus B plus C whole cube. Are you clear? Okay, write down. Next, x double I, prove that value of the determinant is equal to 2 into u v w into u plus v plus w whole cube. Prove. Let del be the determinant having elements v plus w whole square, v square, w square u square u plus w square w square e square v square u plus v whole square. To show del is equal to 2 into u v w into u plus v plus w whole cube. Applying C2 replaced by C2 minus C1 and C3 is replaced by C3 minus C1. Column 2 is replaced by column 2 minus column 1 and column 3 is replaced by column 3 minus column 1. Del is equal to v plus w whole square v square w square. C2 is replaced by C2 minus C1. E square minus v plus w whole square. U plus w whole square minus v square w square. C3 is replaced by C3 minus C1. U square minus v plus w whole square. V square minus v square, that is 0. C2 is replaced by, this is 0. C2 is replaced omega square w square minus w square is equal to 0. V square minus v square, that is 0. U plus v whole square minus w square. C2 is replaced by C2 minus C1 and C3 is replaced by C3 minus w square minus w square equal to 0. Implies this del is equal to determinant having elements v plus w whole square b square w square. A square minus b square, that is a plus b into a minus b. U plus v plus w into u minus v minus w. U plus w plus v into u plus w minus v. A square minus v square, and it is 0. Third column, u plus v plus w into u minus v minus w. It is 0. U plus v plus w into u plus v minus w. Clear? Position as taking u plus v plus w from column 2 and column 3, it gives u plus v plus w whole square. Taking u plus v plus w from column 2 and column 3 into determinant having elements v plus w whole square, b square, W square. It is U minus V minus W, U plus W minus V, and it is 0. 0 into U plus V plus W is equal to 0. Here U minus V minus W 0, U plus V minus W. Here U plus V plus W, taking from column 2 and the column 3, which is same as this. Again apply row 1 is replaced by row 1 minus row 2 minus row 3. Del is equal to U plus V plus W whole square into determinant. This minus this, that means 2VW. U cancel, V minus cancel, minus 2W. This minus this, U cancel, minus W cancel, that is minus 2V. V square U plus W minus V 0. W square 0 U plus V minus W. Taking 2 from row 1, it gives 2 into U plus V plus W whole square into determinant having elements VW minus W minus V. V square U plus W minus V 0. W square 0 U plus V minus W. Clear? If a scalar is multiplied with a determinant, then it will be multiplied in any one of the rows or any one of the columns. 2 is multiplied along row 1, it gives 2VW minus 2W minus 2V. Again apply. C2 is replaced by C2 plus 1 by V C1 and C3 is replaced by C3 plus 1 by W C1. Apply C2 replaced by C2 plus 1 by V C1, so that it will be 0, and it is also 0, which is same as del is equal to determinant, which is same as 2U plus V plus W whole square, determinant having elements VW, V square, W square. C2 is replaced by C2 plus 1 by V C1 minus W plus W, that is equal to 0. C3 is replaced by C2 is replaced by 1 by V C1 and C3 is replaced by C3 plus 1 by W C1. It is 0. This plus 1 by V be cancelled, that is U plus W. 0 plus 1 by V into W square, that is W square by V. 0 plus 1 by V W square, that is W square by V. Third column, C3 is replaced by C3 plus 1 by W minus V plus 1 by V, VW, W cancel, minus V plus V, that is equal to 0. 0 plus 1 by W V square, that is V square by W. V square by W. Next, U plus V minus W plus 1 by W into W square. Minus W plus W cancel, that is U plus V. Clear? Expanding along row 1. Since row 1 contains maximum zeros, implies this del is equal to 2 times U plus V plus W whole square into VW, this into this, that means U square plus UV, U square plus UV, UW plus VW. This into this. V square W square divided by VW, that is minus VW plus minus 0 minus 0 plus 0. Expanding row 1, which is same as 2 into U plus V plus W whole square. VW cancel. VW, U taking common, it gives U plus V plus W, which is same as 2UVW. U plus V plus W square into U plus V plus W, that is U plus V plus W whole cube. Implies del is equal to 2 into U VW into U plus V plus W whole cube. We have to show del is equal to 2 times of U V W into U plus V plus W whole cube. Hence proved. Clear? Okay, write down. Next, question number 12, second bit and third bit. Prove that the value of the determinant is equal to 5x plus 4 into 4 minus x whole square. Let del be the determinant having elements x plus 4, 2x, 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 x plus 4, 2x, 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 x plus 4. The value of the determinant is this. That means to show del is equal to 5x plus 4 into 4 minus x whole square. X plus 4 plus 2x plus 2x gives 5x plus 4. So applying C1 replaced by C1 plus C2 plus C3. It gives 5x plus 4. Implies this del is equal to determinant having elements 5x plus 4, 5x plus 4, 5x plus 4, 2x, x plus 4, 2x, 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 x plus 4. Clear? C1 is replaced by C1 plus C2 plus C3. Which is same as 5x plus 4, taking from column 1, 5x plus 4 into determinant having elements 1, 1, 1, 2x, x plus 4, 2x, 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 x plus 4. Clear? If a scalar is multiplied with a determinant, then it will be multiplied in any one of the rows or any one of the columns. 5x plus 4 is multiplied along column 1 gives this determinant. Clear? This is same as this. 1 minus 1, 0, 1 minus 1, 0. So apply applying row 1 replaced by row 1 minus row 2 and row 2 replaced by row 2 minus row 3. Applying row 1 replaced by row 1 minus row 2 and row 2 is replaced by row 2 minus row 3. Implies this del is equal to 5x plus 4 into determinant having elements 0, 0, 1. 1 minus 1, 0, 1 minus 1, 0. 2x minus x plus 4, x minus 4. X plus 4 minus 2x, that is 4 minus x. It is 2x, 2x minus 2x is 0, 2x minus x, x plus 4, that is x minus 4, x plus 4. Row 1 contains 2 zeros, column 1 contains 2 zeros. We can expand along row 1 or column 1. Expanding along column 1. Del is equal to 5x plus 4, 0 minus 0. The sign of 1 is positive, it is 1. Deleting this row and this column, it gives this into this minus this into this, that it means x minus 4 whole square minus 0, which is equal to 5x plus 4 into x minus 4 whole square, which is same as 5x plus 4 into 4 minus x whole square. A minus b whole square is the same as b minus a whole square. Therefore, del is equal to 5x plus 4 into 4 minus x whole square. Clear? Hence proved. Therefore, del is equal to 5x plus 4 into 4 minus x whole square. Clear? Okay. Next. Prove that the value of the determinant is 0. Prove. Let del be the given determinant having elements sin alpha, sin beta, sin gamma, cos alpha, cos beta, cos gamma. Cos alpha plus beta, that is cos alpha into cos beta. Cos a plus b, that is cos a minus cos b, or we can, that is cos alpha plus delta, cos beta plus delta, cos gamma plus delta. Del is the given determinant, which is same as del is the given determinant. To show del is equal to 0. Now, del is equal to determinant having elements sin alpha, sin beta, sin gamma, cos alpha, cos beta, cos gamma. Cos a plus b is equal to cos alpha into cos beta minus sin alpha into sin beta. Cos alpha plus delta, that is cos alpha into cos delta minus sin alpha into sin delta. Cos beta plus delta, cos beta into cos delta minus sin beta into sin delta. Cos gamma plus delta, cos gamma into cos delta minus sin gamma into sin delta. Clear? To show del is equal to 0. Minus sin alpha into sin delta. It is sin alpha. Sin alpha into sin delta minus sin alpha into sin delta cancel, that is 0. So apply C3 replaced by C3 plus C1 sin alpha into sin delta. It is minus, will be plus, so that it is 0. Cos alpha, cos delta. Here it is cos alpha minus C2 cos delta. That means minus cos alpha into cos delta plus cos alpha into cos delta, that is equal to 0. So apply C3 is replaced by C3 plus C1 sin delta minus C2 cos delta, which is same as sin alpha, sin beta, sin gamma, cos alpha, cos beta, cos gamma. It is 0 since sin alpha into sin delta minus sin alpha into sin delta, that is equal to 0. Here minus cos alpha into cos delta plus cos alpha into cos delta, that is 0. Similarly, it is also 0. It is also 0. Clear? Sin delta into sin beta minus sin delta into sin beta equal to 0. Cos delta into cos beta minus cos beta into cos delta plus cos beta into cos delta, that is equal to 0. Similarly, it is also 0. Expanding along column 3. Expanding along column 3. Expanding along C3. It is called the zero property. The value of the determinator will be 0 if any one of the rows or columns contains all are 0. Column 3, all are 0. All elements are 0. Expanding along this column, it gives 0. Expanding along column 3 implies as del is equal to 0. Hence, proved. Clear? Clear? Okay. Write down. Next, question number 12, fourth bit. Prove that value of the determinant is equal to 1 minus SQ whole square, or 1 minus x into 1 plus x plus s square whole cube. Since AQ minus BQ is equal to A minus B into A square plus AB plus B square. 1Q minus SQ. Let del be the given determinant having elements 1 x s square. S square 1 x s square 1. To show del is equal to 1 minus SQ whole square. One plus x plus s square is this factor. So applying C1 replaced by C1 plus C2 plus C3. 1 plus x plus s square is this factor in right hand side. So we will apply column 1 is replaced by column 1 plus column 2 plus column 3. So del is equal to determinant C1 plus C2 plus C3. 1 plus x plus s square. 1 plus x plus s square. 1 plus x plus s square. No change of column 2. X 1 s square. No change of column 3. S square x 1. Which is same as taking 1 plus x plus s square from column 1. 1 plus x plus s square. 1, 1, 1. X 1 s square. S square x 1. Clear? Taking 1 plus x plus s square from column 1, which gives this result. One minus 1 0, 1 minus 1 0. So applying row 1 is replaced by row 1 minus row 2 and row 2 is replaced by row 2 minus row 3. Applying row 1 is replaced by row 1 minus row 2 and row 2 replaced by row 2 minus row 3. So that we will get 2 zeros in column 1. Del is equal to row 1 minus row 2, that is 0, 0, 1. X minus 1. 1 minus s square. 1 minus s square. S square. S square minus x. X minus 1 and 1. Clear? Okay. And into 1 plus x plus s square. 1 plus x plus s square. Del is equal to 1 plus x plus s square, 1 minus x. Taking 1 minus x from row 1 and row 2. Row 1 and row 2. It contains 1 minus x, it also contains 1 minus x. 1 minus x, so it is 0, 0, 1. Taking 1 minus x from row 1 and row 2. It gives minus 1. It gives x minus x. Taking 1 minus x from row 1 and 1 minus x from row 2, it gives 1 plus x and it is minus 1. So 1 minus s square. 1 minus x into 1 minus x into 1 minus x. Taking 1 minus x from row 1 and 1 minus x from row 2. It is minus 1, it is minus x, it is 1 plus x, it is minus 1. 1 s square 1. Which is same as 1 plus x plus s square into 1 minus x whole square. Column 1 contains 2 zeros. For easier calculation, we will expand along column 1. Expanding along column 1. 0, minus 0, plus minus plus 1. It gives 1 into 1, that is 1, minus plus x plus s square. Expanding along column 1, which is same as 1 minus x into 1 plus x plus s square. 1 plus x plus s square, here 1 plus x plus s square whole square, which is same as aq minus bq. aq minus bq is equal to a minus b into a square plus ab plus b square. So it is 1 minus sq whole square. Implies del is equal to 1 minus s square sq whole square. Hence proved. Here del is equal to, we have to show del is equal to 1 minus sq whole square. This into this is equal to 1 minus s square and whole square. So del is equal to 1 minus sq whole square. Hence proved. Clear? Next, question number 13 and question number 12 are two short questions for 1 mark. If value of the determinant equal to 0, what are the values of x and y? Clear? One minus 1 0, 1 minus 1 0. So applying C1 is replaced by C1 minus C2 and C2 is replaced by C2 minus C3. C1 is replaced by C1 minus C2 and C2 is replaced by C2 minus C3. So the given determinant will be 1 minus 1 0, 1 minus x plus 1, that is minus x, 1 minus 1, that is 0, 1 minus 1 0, x plus 1 minus 1, that is x, in 1 is equal to 0. Row 1 contains 2 zeros, column 1 contains 2 zeros. It is 1 plus y. Implies Expanding along row 1, 0 minus 0 plus 1 into 1 minus y. It is a 1 minus 1 0, 1 minus 1 0, 1 minus x, it is a x, and 1 minus x, that is minus y. Expanding along row 1. So xy minus 0 is equal to 0 implies this xy is equal to 0. That implies x equal to 0 or y is equal to 0. Is the answer. Clear? For 1 mark question. Next, page number 152, question number 12, x double I. The value of the determinant is dash. Apply R1 is replaced by R1 plus R2. Apply row 1 is replaced by row 1 plus row 2. It gives minus cos square x plus minus cos square theta plus cot square theta. 1 plus cot square theta is equal to cos square theta. So minus cos square theta minus 1 is equal to the given determinant this plus this minus 1. Sec square minus tan square. 1 plus tan square theta is equal to sec square theta. So sec square theta minus tan square theta is equal to 1. Minus 0.2, 1.2, that is 1. Cot square theta minus tan square theta 1.2, and row 3 remains silent. Clear? Applying row 1 is replaced by row 1 plus row 2. This plus this, it gives minus 1. Since 1 plus cot square theta is equal to cos square theta. This plus this is equal to plus 1. Sec square theta minus tan square theta is equal to 1. 1.2 minus 0.2, it gives 1, which is same as 0. Since row 1 is equal to row 3, it is the answer. The value of the determinant is 0. Clear? Since row 1 is equal to row 3, the value of the determinant vanishes or 0 if any two rows are identical. That means same. Row 1 and row 3 are equal, so the value of the determinant is 0. Note down. Next, question number 14. Prove that value of the determinant is 0 if a plus b plus c is equal to pi. Let del be the given determinant having elements sin square a, sin square b, sin square c. cot A, cot B, cot C, 1, 1, 1. Let del be the given determinant. We have to show the value of the determinant is 0 to show del is equal to 0. 1 minus 1, that is 0, 1 minus 1, 0. That means apply row 1 is replaced by row 1 minus row 2 and row 2 minus row 3. So that we will get 2 zeros for easier calculation. Applying row 1 replaced by row 1 minus row 2 and row 2 replaced by row 2 minus row 3. Clear? So del is equal to determinant sin square A minus sin square B. Sin square A minus sin square B. Sin square B minus sin square C. And it is sin square C. In column 2, cot A minus cot B. Cot B minus cot C and cot C. 1 minus 1 0, 1 minus 1 0 and it is 1. Clear? Apply row 1 is replaced by row 1 minus row 2 and row 2 is replaced by row 2 minus row 3. Sin square A minus sin square B. What is the formula of sin square A minus sin square B? It is sin A plus B into sin A minus B. Implies as del is equal to sin A plus B into sin A minus B. Cot A minus cot B, that is cos A divided by sin A minus cos B by sin B and 0. Second row, sin square B minus sin square C. The formula for sin square B minus sin square C, that is sin B plus C into sin B minus C. Clear? Sin B plus C, sin B minus C is equal to sin square B minus sin square C. Cot B minus cot C, that is cos B divided by sin B. Cos C divided by sin C and it is 0. Clear? The third row remains silent, that is sin square C, cot C and 1. Clear? Which is same as A plus B plus C is equal to pi. So A plus B is equal to pi minus C. Sin A plus B is equal to pi minus C into sin A minus B. Here the LCM is sin into sin B, that is sin B into cos A. Sin B into cos A minus cos B into sin A divided by sin A into sin B and 0. Clear? Sin A and sin B is the LCM. So the numerator is sin B into cos A minus cos B into sin A. B plus C is pi minus A. Sin pi minus A. B plus C is equal to pi minus A, since A plus B plus C is equal to pi. Here the LCM is sin B into sin C, which gives sin C into cos B minus cos C into sin B divided by sin B into sin C. The third row remains silent, that is the sin square C cot C, it is 0, it is 1. Clear? Okay. Sin pi minus theta is equal to sin theta. Sin pi minus C is equal to sin C. Sin C into sin A minus B. Here sin B minus C. Sin pi minus A is equal to sin A. Sin A into sin B minus C. Sin square C. Here sin B into cos A minus cos B into sin A. It is the formula sin B minus A. The numerator is sin B minus sin B into cos A minus cos B into sin A. Whole divided by sin A into sin B. Here sin C into cos B minus cos C into sin B, that means sin C minus B. Whole divided by sin B into sin C. And cot C. 0, 0, 1. Clear? Now expanding. Column 1. Expanding along column 3. It is a column 3. Since column 3 contains 2 zeros, del is equal to del is the given determinant, this into this, which gives 0 minus 0 plus 1 into Expanding along column 3. Zero minus 0 plus 1 into this into this. This into this, that means sin C and sin C cancelled. Sin C cancelled. Sin A minus B, sin A minus B sin A minus B into sin C minus B whole divided by sin C cancel, sin A minus B into sin C minus B whole divided by sin B into sin C cancel whole divided by sin B minus this into this, sin A and sin A cancel, sin B minus C, sin B minus C, sin B minus C into sin B minus A, sin B minus A divided by this into this divided by sin B, which is same as sin A minus B into sin C minus B divided by sin B minus sin B minus C, sin B minus C is same as C minus B into sin A minus B divided by sin B. Since sin minus theta is equal to minus sin theta, sin C minus B gives 1 minus, sin A minus B gives 1 minus. So this is the same as sin C minus B into sin A minus B divided by sin B. Since sin minus theta is equal to minus sin theta. Clear? Sin B minus C, sin C minus B gives 1 minus. Similarly, sin A minus B gives 1 minus. So the result will be minus sin C minus B into sin A minus B. This is same as this, which is equal to 0. Implies del is equal to 0. Hence proved. Clear?